welcome back to our science videos. Okay, today we will continue in lesson 1. The first thing in lesson 1, that types of chemical reactions. RXN means reaction. Okay, what are the types of chemical reaction we will study in this semester? We have three main types of chemical reaction. Let's figure out what are they. The first one, something called thermal decomposition. Thermal decomposition. And we will know the meaning of chemical decomposition right now. And the second type we will study is substitution reaction. Substitution reaction. Okay, and the third one we will have is something called oxidation and reduction. Yes. Okay, so what are these types? Thermal decomposition, substitution reaction, oxidation and reduction. Okay, let's figure out what are they in closer focus. Thermal decomposition, substitution reaction, oxidation and reduction. First of all, thermal decomposition. Okay, thermal decomposition itself has many types. First of all, we have decomposition of metals oxide. So decomposition of metal oxide, and the decomposition also of metal hydroxide. Metal hydroxide, and also decomposition of metal carbonate. Metal carbonates, and also metal sulfates. Metal sulfates, and also metal nitrate. Metal nitrate. Okay, so 1, 2, 3, 4, and 5. 5 types of thermal decomposition reactions. Okay, first of all, again, metal oxide, metal hydroxide, metal carbonate, metal sulfate, metal nitrate. Okay, this is great. But of course, we will take each one of these these 5 types, each one alone with a lonely thing, to figure out what's inside it. First of all, metal oxide. Metal oxide. Okay. So we have metal oxide. What about a metal oxide? Let's make oxides. Okay. But before going to metal oxide, let's figure out what is the meaning of thermal decomposition. Thermal, as we know, it means heat. Decomposition means breaking up. So thermal decomposition means breaking up compounds by using heat. For example, if we have a compound that comprises of A and B, and of course they are attached with each other, I want to break it down, so I heat them. So when I heat them, they break down. So this process is called thermal decomposition because I used heat to break it down. Okay. Now we will go to our booklet and to see the booklet and the revision of the booklet. This is where we end in the last lesson, in the last video. Okay. This is thermal decomposition, the first type of decomposition. Thermal decomposition of course, we have a compound AB, and we use this symbol. The triangle 1 is a symbol of heat. So instead of writing heat or heating, okay, just write a small symbol of a triangle. So if we have a compound AB and we use heating, so the compound will break up into two substances, substance A and substance B, isolated from each other. For example, if we have some metal oxide, we will heat them to produce metal and oxide. Okay. For example, we have mercuric oxide. Mercuric oxide. What is the symbol of mercuric oxide? The symbol of mercuric oxide it is HgO. When I heat it, we will produce 2Hg plus O2. So the HgO is called mercuric oxide, and the Hg is mercury plus O2 is oxygen. So these are the thermal decomposition of some metal oxides. Okay, we have some colors here is very important. Mercuric oxide is red in color, and mercury, only the mercury is silver in color. Mercury is silver in color. Okay, so again, if we have mercury, if we have mercuric oxide HgO, okay, let's have it right now with this color. Okay, if we have mercuric oxide HgO, okay, it's a bad color, very bad color. Okay, HgO, and we add some thermal or heat energy to it, so the way will break up to produce Hg, which is mercury, and O, which is oxygen. Of course, the O is gaseous, so it will evolve. Okay, Hg is red. HgO, sorry, mercuric oxide is red. The Hg only is silver. Okay, the oxygen, of course, is colorless. Okay. Some metal hydroxide. Metal hydroxide, the metal we will use it right now is copper hydroxide. Of course, it's OH, so we'll copper hydroxide. Copper hydroxide. Of course, if we put that to heat, this compound will break up to two components. Cu will take the oxygen from hydroxide and leave it with H2O. So CuOH by 2 will produce CuO plus H2O. This is copper hydroxide, and this is copper oxide, and this is water vapor. What about the colors? The color of copper hydroxide is blue, and the color of copper oxide is black. Blue, black, blue, black. Okay. What about most metal carbonate? Metal carbonate, metal, we will use a metal right now is copper, okay? Copper and carbonate means CO3. So copper carbonate is CuCO3. This is green color element, compound, sorry. This is green color compound. We'll heat it, the symbol of heating is delta, and this will produce CuO. Of course, we know that copper love oxygen, so it can break up. So we have CuO. It's very difficult to break them down to produce CO2. So again, copper carbonate is green color. If we put that to thermal or heat energy, this will produce CuO, which is copper oxide. We know that copper oxide is black in color from the previous example, and plus carbon dioxide. Okay, of course, carbon dioxide is gaseous compound, will evolve. Okay, what about most sulfate? What is the meaning of sulfate? Sulfate, sulfur means S, sulfur. Sulfate is SO4, so the sulfate is SO4. Again, sulfate is SO. And of course, the metal we will use it right now is copper. So copper sulfate, copper sulfate. Let's make the example. Okay, copper sulfate. Copper sulfate is blue in color. This will produce CuO, of course. Copper love oxygen, so will produce CuO, copper oxide. We know that is black in color, plus sulfur trioxide. Sulfur trioxide. Okay, this is obvious. Okay, let's now speak about the most metal nitrate. What's the meaning of the word nitrate? Nitrate means NO3. The metal we will use now is Na. It's very close to NO. So NaNO3. We have NaNO3. This is called sodium nitrate. Sodium nitrate. Sodium nitrate, if it is heated, it will produce sodium nitrite, NaNO2. So we have NO3 and NO2. NO3 is nitrate and NO2 is nitrite. Okay, NO3 is nitrate, NO2 is nitrite. Both of them are chemical groups, so they can't be found lonely. They are found attached to another element. For example, if we have NO3 attached to sodium, so it is sodium nitrate. Attached to aluminum, so it is aluminum nitrate, and so on. Okay, so we have sodium nitrate, white color. If we add some heat to it, so it will produce two components, sodium nitrite, which is NaNO2 plus oxygen. The sodium nitrite is yellowish white color. So the color of nitrite, which is white, will be yellowish, a small amount of yellow. Okay. Now we will finish the thermal decomposition activities, the thermal decomposition examples and types, the 5 types of thermal decomposition. Now we will take some life application of thermal decomposition activities. The life application we have today is airbag. What is the meaning of airbag? Airbag, we found it inside cars. It is blow up when we have an accident to make it safer for the driver and the passengers when they ride a car. Okay, the importance of it. They are considered one of the most important safety means in cars at emergencies. The idea of operation. It has inside it NaN3. Na is sodium, N is nitrogen. So NaN3 is sodium azide. Sodium azide. Not acid. Of course, it's wrong. Sodium azide. When we add it to an electrical spark inside the car, it has an electric spark while accidents. So this will break down to have the sodium and the nitrogen. Okay, so the idea of operation again, on occurrence of a car accidents or crash, rapid decomposition and explosion happen to the substance of sodium azide, not acid, azide, which is present inside the airbag, forming sodium and nitrogen gas evolve. Of course, the nitrogen gas will evolve. Okay, this is the airbag. Substitution reaction. Substitution reaction is the second type of reaction we will have in this term. We will study it in the next video, of course. Have a nice time and study your lessons step by step. Don't leave it to the end of the semester. This is my advice, and goodbye.